So distance, how far an object is moved. Displacement, distance and direction of an object changes position from a starting point. All right, and this is the key difference. Okay, distance is the total ground that you've covered. Displacement is how far you've gone from where you started. All right, so I have a little device I'm going to use as kind of a demonstration. Okay, this is called a trundle wheel, and it is 1 meter in circumference. Okay, so we've used meter sticks before, right? We've used meter sticks before, so this is basically the same distance here, but just rolled up in a wheel. And what it does is that every time you go 1 meter, it clicks. Okay, so every time you go a meter, it clicks. So we're going to measure the distance that I'm going to travel as I walk around over here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I just traveled 8 meters, right? That was my distance. What was my displacement?
Wasn't it the same? Because, no, you ended at a different place.
I started right here, right?
No.
And I ended right here.
So 0.
So 0. My displacement is 0. Okay? So displacement takes into account where you started and where you finished. Distance does not. Distance doesn't care where you started, where you finished. It's just the amount of ground that you covered. Displacement is all about where did I start, where did I finish. All right? Every single day, what is your displacement?
0, because I end up back in bed.
Exactly. You wake up in your bed, right? You go about your day. You do whatever it needs you to do. You go to school, you go hang out with friends, whatever, but you always come back and sleep in your bed. Right? So your displacement overall is 0. The distance you traveled is how far you went. It's the same thing, with a car, right? The car, it's parked in the garage, comes out of the garage, goes to work or wherever, runs errands, comes back, it's parked in the garage. Now, the car keeps track of how far it's gone, right? It's got the little trip thing that records the overall time. I'm blanking what that's called. Yeah, there's some specific name for it, but I can't remember what it's called. Yeah, the odometer. Yeah, the odometer. So the odometer, right, it measures the distance that the car has traveled over its entire lifetime. It's not measuring displacement, right? It's not measuring how far it's gone from where it started. Okay, that's just measuring your distance. If you look here, all right, we've got a person, they started at this point right here, okay? They want to get across the river. River's moving too fast, it's too cold, they can't swim across. They've got to walk across, okay? So they got to walk, find a bridge, go across, and then come back down to the other side. What is the distance traveled by this person? Okay, what's the... This is 8.2, and this is 1.8. What's 8.2 plus 1.8? 10. So that's 10. 14.5. So the total distance was 14.5. The displacement is only 2.7 kilometers. Okay?
Wait,
that's
14 kilometers just to get around?
Just to go all the way around, yep. Right? Okay? That's the difference between distance and displacement. Any questions before we move forward? Alright. So, another way we can describe the motion of an object is if we talk about the speed of the object. Okay? Speed is the distance an object travels per unit of time. And there are 3 different ways that we can kind of talk about speed. We can talk about constant speed. Okay? This is a speed that does not change. Think about setting the cruise control on a car. If you set it at 40 miles an hour, it's going to stay at 40 miles an hour. It's not going to change. That's what we would consider a constant speed. What is your speed right now sitting in your chair?
0.
Are you experiencing a constant speed?
Yes.
Yes, you are. Because is your speed changing? No, it's not. It's staying 0. Okay? So you can have a constant speed that is a speed of 0. It's constant. It just all constant means is it's not changing.
Is it speed at any given point in time?
Yes, that's correct. Yeah. Instantaneous speed is the speed at any given point in time. Sorry, Usain Bolt was getting a little crowding things out a little bit. So the instantaneous speed is we're going to pick a moment in time. We're going to say, what's the speed right now? and we measure that speed. So this would be like, you're driving, and you look at your speedometer, and you see what your speed is, right? That's only your speed at that moment. You might have to slow down a little bit, and now you have a new speed. That's your new instantaneous speed. So instantaneous speeds are just picking out a speed at a single moment in time. The last one is your average speed. Okay? Average speed is the speed over an entire trip. So if you're driving from here to downtown, right, you're going to have to hit some lights, slow down, accelerate. Okay? Your average speed is the total distance you covered divided by the amount of time it took. And your average speed is going to be somewhere, in the middle, somewhere between 0 and probably like 40, 45, right? Your maximum speed, you might get down, going 45, going down MLK, right? And then at some stoplight, you're going to be at 0. So it's going to be somewhere in the middle. Average speed is not an average as in like we add up 5 numbers and then divide it by 5. Okay? That's an arithmetic or a mathematical average. We're going to be talking about average speed. It's a little bit different. Okay? So you kind of have to disengage your mind of what you think average means in this particular case. Any questions? Okay. When we talk about speed, we're talking about a rate. And we've talked about rates before. We talked about rates at the beginning of the very beginning of the year when we were doing a lot of graphing and we were talking about slopes. Okay? A rate describes any change of something over time. When we talk about speed, what are we talking about changing over time? Distance or our position. Okay? We're talking about the amount of ground that we're covering in a particular amount of time. What's the speed, what's the rate that we use to describe our speed when we drive cars? Miles per hour. That is a rate. We're saying in 1 hour, if we maintain this speed, we can go 60 miles. Okay? So in 1 hour, if we drive 60 miles per hour, how many miles have we traveled? 60 miles. What if I drive for 2 hours at 60 miles per hour? 120 miles. Right? Because that's how many miles I go each and every hour. What if I only drive for 30 minutes? How far would I go? 30 miles. Okay? The formula for speed is distance divided by time. Distance divided by time. How far did I go? How long did it take me to get there? That's my speed. The way that it is going to look on the formula sheets, and you all will have formula sheets. I said this before when we were doing density, that you would never need to memorize a formula, but you have to memorize how to use the formula. Okay? The way that it's going to look on those sheets is that you're going to get this V, okay, with a line over top. That is average velocity or average speed is equal to delta D. What's delta? What's delta? Change in distance divided by change in time. Okay? So the delta is change. So if I leave the school, okay, at, let's say, 4 o'clock, and I get home at 4:15, what is my delta T? 15 minutes, right? Okay? Now, if that distance is 1 mile, okay, right, then my delta D is going to be 1 mile, right? That's the distance that I've covered. So what would be my rate? If it takes me 15 minutes to get home, to go 1 mile, 1 divided by 15, okay? And then we would figure it out, right? That would be my rate. That'd be pretty slow, right? I'm probably walking, if that's how slow I'm going, okay? But that's when we're talking about speed in terms of distance divided by time. Any questions? Yes?
What's right? Those two cursive runs, or just the one?
You just need just the formulas would be fine. I mean, the rate thing is good. It's not bad. It's okay if you did write it. It's not a problem. You're always welcome to have more stuff written down. Okay. Everybody good? Okay. So we can make graphs of speed, and we will make graphs. We're going to make graphs in two ways. Number one, I'll give you some data and you'll graph it. The other way we're going to do it is that we have devices that will measure your motion. They're motion detectors. Okay? And they're going to use radar waves, and they're going to bounce them off of you, and they're going to measure your position, and they're going to measure how fast you're going. Okay? So we'll do this in a couple different ways. But let's take a look at this first line. Okay? Would you consider this a straight line or a curved line? Okay, it's a straight line, right? Does that mean that the slope is the same all the way through the line, or is the slope different at different points on the line? Okay, the slope is the same throughout the entire line. All right? What's on the y? Right? Which is a measure of. Okay, what's on the x? What do we know about slope? What's the formula for slope?
Y minus y1 over x2 minus x2.
Right? And what's the other way of saying that? Rise over run. What is that? Distance over. What was our formula? Distance over time. The slope of this line is our speed. Okay? Is our speed changing? So this would be considered a constant speed. Okay? This line would be considered a constant speed, and this is a positive speed, right? We are going in a direction positively. The slope is positive, so we are moving forward. Okay? What about this line? Is the slope the same for the second line? So that would be a changing speed. Now, let's think about it. If we're changing our speed, let's imagine a scenario we're in a car. If we're changing the speed, what is the car doing? It could be, or it could be speeding up. Now let's think about, in this case, is this a negative or positive slope? So what do you think? Accelerating or decelerating? It's going to be accelerating. Okay, it's speeding up. Because it's going faster and faster and faster. It's covering more space in less time. All right? So a straight line is indicative of a constant speed. For a position versus time graph, a curved line is indicative of an object that is accelerating. And again, we're going to look at this in a lot of different ways. Now, let's compare these two graphs, right? These have a negative slope. So what do you think the object is doing? These are not on there. Is it decelerating? Is the line curved? No. If it's accelerating or decelerating, it's got to be a curved line. These are straight lines, right? So it's not accelerating or decelerating. What is it doing?
Not going as fast.
It's going in the opposite direction. It's going backwards. Okay, that's right. It's in reverse. Okay? So a negative slope means that the object is moving backwards. Positive slope moving forward, negative slope moving backwards. Now, if we're just to compare these two lines, which one of them is going backwards faster?
The right.
Why the one on the right?
Because it's down.
A steeper slope, that's right. It's got a larger slope. Steeper slope, okay? So, below the graph, it says, what does the slope of a distance versus time graph represent? It represents the speed or the velocity. Okay, so this is what you want to write down in that fifth box. It says, what does the slope of a distance versus time graph represent? Speed or velocity. So the fifth box, speed or velocity. Slope is equal to speed. And specifically, we're talking about the slope of a position versus time graph. We're also going to, not today, but later on, take a look at a speed versus time graph. Okay? And you're going to need to be able to differentiate between those two. Again, we'll have lots of practice for you to have an opportunity to figure those two things out. Okay? Questions? Okay, now, we've been talking a lot about speed, but I've been throwing in this word velocity every once in a while. Okay? So let's define velocity, and I'm going to explain what the difference is between speed and velocity. Okay? This is a difference that, in terms of your everyday lives, is not going to make that big of a difference. But when we start getting into some more scientific things, it's going to make a difference. And what we define velocity as is both the speed and direction of an object's motion. Both the speed and the direction of an object's motion. So let me give you an example. How many of you all either drive a car or have done the driving portion of driver's ed? Okay, so we got some. All right. So when you drive the car forward, what happens to the speedometer? It goes up. Okay. What about when you put the car in reverse? It still goes up. That is speed. The speedometer only measures your speed. It doesn't care if you're going forwards or backwards, right? It still gives you a positive number. If it was going to measure velocity, when you put the car in reverse, it would actually go the opposite direction and go negative. Okay? It would become a negative number instead of a positive number. Because that negative tells you that you're going backwards. Okay? That's the difference between speed and velocity. Speed, doesn't matter what direction you're going, it's just going to give you a positive number. If it's velocity, it's going to give you a direction. And that can either be positive or negative, or we can say that we're going 50 miles per hour north. That would be considered a velocity because I'm giving you a direction. Or I could say I'm going 40 miles per hour west. That would be considered a velocity. Okay?
Yes, sir.
Any questions? All right.
Could it still be velocity if it gives you a direction, right? It doesn't have to be negative.
It doesn't have to be negative, correct. As long as you've got a direction associated with it, it's a velocity. Okay? And we're going to talk about this more. We'll talk about this more in just a little bit about the difference between speed and velocity, and also the difference between distance and displacement. But before we get to that, I promised you that we were going to watch a little video that was going to explain some things about frame of reference, or a reference point. Okay? So we're done with your notes for now, so you can go ahead and put the notes away, but leave the other stapled pieces of paper out. Okay, so you can put the notes away, leave the stapled piece of paper out.
When are you going to go to the football field?
We'll do that in a couple weeks. All right.